Section 3.3. Examples of creating good functions with Copilot. In this section, we're going to write a bunch of functions with Copilot. We think you'll get a much better feel for functions by seeing concrete examples, and we'll code them entirely in Copilot to help you see the cycle of function design we just described. Although our goal in this chapter isn't to help you read code just yet, we'll see programming features, sometimes called constructs, in the solutions that are very common in code. For example, if statements, loops. So we'll point those out when we see them. Then, in Chapter 4, we'll say more about how to read this code in more detail. Many of the functions we're about to work on are unrelated to each other. For example, we'll start with a function about stock share prices and move to functions about strong passwords. You typically wouldn't store unrelated stuff like this in the same Python file. Because we're just exploring different examples of good functions, feel free to store all functions in the same Python file, perhaps named function ch3.py or function_practice.py. Section 3.3.1. Dan's stock pick. Dan is an investor in a stock called Apple. He purchased 10 shares for $15 each. Now, each of those shares is worth $17. Dan would like to know how much money he has made on the stock. Remember that we want to make our function as general as possible. If the only thing our function does is calculate this exact Apple situation, it wouldn't be that useful in general. Sure, it would help Dan right now, but what about when Apple's share price changes again or when he is interested in another stock entirely? A useful general function here would take 3 parameters, all of which are numbers. The first parameter is the number of shares purchased. The second is the share price when the shares were purchased, and the third is the current share price. Let's call this function money_made, because it's going to determine how much money we've made or lost on the stock. In general, you want to name your function as an action word or words that describe what your function is doing. With that, we have enough to write the function header.
See this code?
Now, we need a docstring. In the docstring, we need to explain what each parameter is for by using its name in a sentence. We also need to include what the function is supposed to do. Adding our docstring, here's the full prompt we provide to Copilot.
See this prompt?
After typing that prompt, go to the next line and press the Tab key. Copilot will fill in the code for the function. Don't worry that the code gets indented. The code of functions is supposed to be indented, and in fact, it's an error if it isn't. Here's what we got from Copilot.
See this code?
This code seems sensible. In the parentheses, it figures out the difference between the current price and the purchase price. The minus is used for subtraction. And then it multiplies that by the number of shares that we have. The asterisk is used for multiplication. Inspecting code like this is a useful skill, and we'll get serious about it in the next chapter. Another useful skill is testing the function. To test the money-made function, we call it using various inputs and observe the output in each case. We could do this by asking Copilot to call the function, and then we run our program, much as we did with our larger function. We could then ask Copilot to change the function call by asking it to call the function with a different input, and then we would run our program again, repeating as many times as needed. However, we find it easier and more convenient to call the function ourselves from an interactive window. This way, we can call the function as many times as we like without going through Copilot at all, and without cluttering up our program with stuff we're going to delete anyway. To try this interactive approach, select or highlight all the code of the function, and then press Shift-Enter. You can access a similar interactive session by selecting the text, right-clicking, and choosing Run Selection or Line in the Python window. But the guidance here is if you use Shift-Enter. Figure 3.3 shows what this looks like if you select the text of the function and press Shift-Enter.
Figure 3.3. Running Python in an interactive session in VS Code. Note the 3 greater than symbols at the bottom of the terminal tab.
At the bottom of the resulting window, you'll see 3 greater than symbols. This is called a prompt, and you're allowed to type Python code here. This prompt has nothing to do with the kind of prompt that we use when interacting with Copilot. It will show us right away the result of the code that we type, which is convenient and fast. To call our money-made function, we need to provide 3 arguments, and they will be assigned left to right to the parameters. Whatever we put first will be assigned to num shares. Whatever we put second will be assigned to purchase share price, and whatever we put third will be assigned to current share price. Let's try this. At the prompt, type the following and press Enter, or Shift-Enter. Don't type the 3 greater than symbols as that's already there. We're including it throughout the book to make it clear where we're typing. Figure 3.4 shows an example of running the function in the terminal at the Python prompt.
See this code?
You'll see the following output.
See this code?
Is 20 correct? Well, we bought 10 shares and each of them went up $2, from $15 to $17. So we did make $20. Looks good.
Figure 3.4. Calling the money-made function from the Python prompt in the VS Code terminal.
We're not done testing, though. When testing a function, you want to test it in various ways, not just once. All one test case tells you is that it happened to work with the particular input values that you provided. The more test cases we try, each testing the function in a different way, the more confident we are that our function is correct. How do we test this function in a different way? We're looking for inputs that are somehow a different category of input. One not-so-good test right now would be to say, what if our stock went from $15 to $18 instead of $15 to $17? This is pretty much the same test as before, and chances are that it will work just fine. A good idea is to test what happens when the stock actually loses money. We expect to get a negative return value in this case, and it appears that our function works just fine with this category of test. Here's our function call and the output returned to us.
See this code?
What other tests can we do? Well, sometimes a stock price doesn't change at all. We expect 0 in this case. Let's verify it.
See this code?
Looks good. Testing is a combination of science and art. How many categories of things are there to test? Are these 2 calls really 2 different categories? Have we missed any categories? You'll improve your testing ability through practice, and we'll spend all of Chapter 6 talking about testing. For now, it looks like our money-made function is doing its job. It's possible for a function to use variables, rather than just its parameters, in its code, and we want to show you an example of that now so that you're ready when you see Copilot doing it. Here's an equivalent way to write the code for our money-made function.
See this code?
This code may even be easier to read for you. It first figures out the difference in share price, and then it multiplies that by the number of shares. We encourage you to test this version to help convince yourself that it's still correct. Section 3.3.2. Leo's password. Leo is signing up for a new social network website called Programmer Book. He wants to make sure that his password is strong. Leo starts with a modest definition of what it means for a password to be strong. It's strong if it's not the word password and not the word QWERTY. Those are terrible passwords for sure. But in reality, we have to do way better than this definition to ensure that our password is strong. A helpful function would be one that takes a proposed password and tells us whether it's strong or not. Unlike our previous functions in this chapter, we're not dealing with numbers here. The parameter, the password to check, is text, and the return value is supposed to indicate some yes or no result. We need new types. The Python type for text is called a string. There are zillions of possible strings because we can use a string to store whatever text we want. The Python type for a yes or no result is called a Boolean or bool. A bool has only 2 values, true or false. All right, we're ready to prompt Copilot. For functions that return bool, true or false, values, we usually name the function as has underscore x, is underscore x, or similar using some other verb that implies a true or false result.
See this prompt.
In response, here's what Copilot wrote for us.
See this code?
Look over that code for a moment. That exclamation mark equals operator is the not equal operator, and each string that doesn't count as a strong password is in single quotation marks. We're going to use quotation marks every time we need to specify a specific string value. Again, we'll talk more about how to read code in the next chapter, but for now, we hope that the code makes a fuzzy sort of sense. It looks like it's checking that the password isn't password and isn't QWERTY, which matches our definition of a strong password. Now let's make sure that this function does indeed work by making a few test calls. We'll start by testing the passwords that aren't strong. We had better get back false for each of these, and we do.
See this code?
Good. Now, let's try a strong password. We need to see true here.
See this code?
Good stuff. We now see that the function sometimes returns false and other times returns true, so at least it's not always returning false. Let's try one more.
See this code?
Well, technically true is correct, but wow, is Leo a bad password? We should really have done better with our definition of a strong password. Let's change our prompt to give a more reasonable definition of what it means for a password to be strong. Here's our next prompt and what Copilot gave us.
See this prompt?
That for care in password that shows up a few times here is a way for Python to consider each character of the password. It enables something called a loop, which is a key topic that we'll study in Chapter 5. Of course, it's possible that you didn't get the same code from Copilot as we did, but based on the code that we got, it looks like the first piece is looking for any uppercase character, the second piece is looking for any digit, and the third is looking for something that's not an isalnum. Maybe isalnum means is alphanumeric. Does that include special symbols? And if so, which ones? Let's test this function to see how well we're doing.
See this code?
Uh-oh, we got the wrong answer for that third password. It looks pretty strong, but it's not, because it lacks a special symbol. Our function returned true, but that's the wrong return value. It was supposed to return false. The code that Copilot gave us is wrong. Maybe the code that you got worked fine, but we didn't get so lucky. And it's important we know how to identify, like we just did, when the code is wrong and then fix it. It's not important to know why it's wrong right now, but if you're curious about why our prompt may have given us the wrong behavior, it's because we didn't specify what we meant by a special character, and the code it gave us counts spaces as special characters. At this point, as we begin to troubleshoot our wrong code, we have two options. One option is to press Ctrl-Enter and look through the other suggestions that Copilot gives us. Maybe one of those suggestions will have something to do with special symbols that looks different from the one that didn't work. Indeed, on our computer here we see such options, including this one.
See this code?
Test this function with strings such as Leo, N3WY0RKJ375, and N3WY0RKJ375, and you should see that the function works well. Our second option is to do some prompt engineering, which means adjusting our prompt to influence what Copilot gives us. In our original prompt, we talked about special symbols. This, in retrospect, is vague. We probably meant something more specific, such as punctuation. If we specifically talk about punctuation in our prompt, we get this interaction with Copilot.
See this prompt?
Looks good. That last line is talking about punctuation, which is hopeful. Let's test it here.
See this code?
Looking at the bottom of that error message, you'll see that string isn't defined. Copilot wants to use a module called string, but it's a module that needs to be imported before we can use it. This not defined result can happen for various types of errors related to names not being found, and oftentimes the culprit is a module that hasn't been imported. There are a lot of modules in Python, but the string module is well known. As you work with Copilot more, you'll learn which modules are commonly used so you know to import them. You could also do a quick internet search to ask, is string a Python module? And the results would confirm that it is. What we need to do is import the module. Note that this is similar to what happened in the code that Copilot generated for us in Chapter 2. Back then, Copilot was using the CSV module, which is a module already installed with Python. The string module is similarly included with Python. Copilot just forgot to import it. As we discussed in Chapter 2, some modules do need to be manually installed, but the string module isn't one of them. So, we don't need to install string, we just have to import it. Importing modules. There are a number of useful modules available in Python. In Chapter 2, Copilot used the CSV module to make it easier to deal with comma-separated values, CSV, files. But for Python code to take advantage of a module, we have to import that module. You might ask why we don't have modules available to us without importing them, but that would massively increase the complexity of the code and what Python has to do to run code behind the scenes. Instead, the model is to include modules if you want to use them, and they aren't included by default. Let's add import string at the top of our code.
See this prompt?
Now we're in good shape.
See this code?
That last one is true. It's a strong password because it has the $ punctuation added to it. We hope that you're now convinced of the value of testing. Sometimes new programmers don't test their code. They assume that the code they write is correct because it made sense to them. An interesting difference between novice and experienced programmers is that novices often assume their code is right, whereas experienced programmers assume their code is wrong until thoroughly tested and proved otherwise. Beyond this, we find that new programmers sometimes fail to test well because it's disheartening to learn that the code is wrong. But it's better to know now rather than later when others are using your code in a serious application. Finding errors through testing is actually a good thing. Section 3.3.3. Getting a strong password. Now that we have a function that tells us whether a password is strong or not, let's write a function that obtains a strong password from the user. It will ask again and again for a password until the user types a strong one. This is the kind of code that websites use when they tell you, "Sorry, your password is too weak, try again." What should the header for such a function look like? Well, it's going to ask the user for a password, but we won't have a password parameter. In fact, we won't have any parameters at all because the function doesn't need any information to do its job. It just has to prompt the user, and the user will type the password at the keyboard. When the function has done its work, it will return the strong password, so it will continue to return a string as the output. Let's try this prompt.
See this prompt?
We get the following code from Copilot as a result.
See this code?
That while keyword creates another kind of loop, this one continuing as long as the entered password isn't strong. Copilot is also smart enough to call our earlier isStrongPassword function to determine what counts as a strong password. As you'll see in future chapters, using functions as building blocks in this way is precisely how large programs are built. You'll often notice Copilot calling your earlier functions to solve later ones, much as we observed here. Let's test this. Highlight all the code from our two password functions and press Shift-Enter. We'll call the function that we want to test. Then, try typing passwords, pressing Enter after each one. You'll notice that it keeps asking until you finally provide a strong password.
See this code?
Notice that it stops asking us for a password when we finally provide a strong password. Then, we see the string in quotes that it returned, which is, indeed, our strong password. Section 3.3.4. Scrabble Scoring. One of Dan's favorite board games is Scrabble. Have you played it? If not, all you need to know is that you have some tiles in your hand, each with a letter on it, and your goal is to form a word using any combination of those letters. You don't need to form the word exclusively with your tiles. You can attach those letters to existing letters on the board to create longer words. But we're not going to worry about that here. The important thing for us is that different letters are worth different numbers of points. For example, an A is worth only 1 point because A is such a common letter. But Q and Z, those doozies are each worth 10 points because they're so tough to use. Or should we say puzzling to use? Yeah, that's better. To calculate the score for a word, we add up the scores for each of its letters. For example, the score for Zap would be 14. That's because Z is worth 10, A is worth 1, and P is worth 3. Dan would like a function that, given a word, tells him how many points that word is worth. Okay, so we need a function that takes a word, which is just one parameter. Let's try this prompt, where we've included the number of points that each letter is worth per official Scrabble rules.
See this prompt?
For this function, Copilot isn't filling in the whole body for us with one press of the Tab key. Tab is also used to indent the code, which we also need to do here before Copilot will present us with code. So, we're having to press Tab, sometimes once for the indentation, and then again for Copilot. Wait for the code to appear, then press Tab to accept that code, then press Enter again for more code to be presented and repeat the process. Getting Copilot to suggest code may require pressing Tab or Enter. We find that Copilot will sometimes pause in giving suggestions until you press a key to help prompt it. As mentioned in Table 2.1, if you're giving it comments, Copilot will sometimes just want to give you more comments as suggestions. Pressing Enter another time can often trigger it to start generating code instead. Other times, pressing Tab will cause it to continue providing suggestions. Refer to Table 2.1 if Copilot isn't generating code for you. Finally, after doing that a few times, the entire code unfurls, and we get the following.
See this code?
Notice that all the letters of the alphabet are accounted for here, and the number of points that each category is worth is on the following line. We'll discuss this overall kind of decision structure in the next chapter, but at a high level, it's walking through the word character by character, and for each character, figuring out which letter it is and adding the appropriate number of points for that letter. Let's test this to make sure our code is performing the way we want. We know that the word zap should be worth 14 points, and it is.
See this code?
Let's try a couple more. In each case, calculate by hand what you expect the answer to be. That way, you'll know if the code is doing the right thing.
See this code?
There are many ways to write correct code for a function. If you press Ctrl-Enter and look at the Copilot suggestions, you may see different types of code. It doesn't necessarily mean that one of these types is right and the others are wrong. For example, here's another solution for num_points that we got from the other Copilot suggestions.
See this code?
Notice here that each letter is listed individually along with its number of points. This structure with the letters and points is called a dictionary, and again, you'll learn about dictionaries properly in a later chapter. The point for now is just that there are often multiple, equivalently good ways for Copilot to write the code for a function. Give this one a try with some test cases before you continue. Section 3.3.5. The best word. Let's continue with the Scrabble theme. Suppose that Dan has a bunch of words that he can make right now, but he doesn't know which one will give him the most points. Should he make the word zap, pack, or quack? It would be nice if we had a function that could take a bunch of words and tell us which is the best one. How many parameters should we have in such a function? Your first instinct may be 3 parameters, one for each of the 3 words in our options. But that wouldn't be very flexible. After all, what if we want to know the best of 5 words, 10 words, or 50 words? We would like our function to work no matter how many words we're considering. The trick is to use a function with one, yes, just one, parameter, which is a list of words. Just like numbers, strings, and dictionaries, a list is a type supported by Python. It's incredibly useful because it allows us to collect as many values into one place as we like. We can prompt Copilot like this to get the function that we want.
See this prompt?
How will Copilot know how many points each word is worth? Well, it can call that numPoints function that we wrote in the previous section. Here's the code that Copilot gives us.
See this code?
We need to be careful to call this function correctly when testing, using.
See this code?
Won't work because that's passing values for 3 parameters, not 1. The right way to call it is to put the words inside square brackets, like this. We'll see more about lists in the next chapter.
See this code?
But as usual, you shouldn't be content with just one test case. This function should work in other valid but perhaps strange cases too, such as when we have only one word in the list.
See this code?
However, we wouldn't test this function on a list that has no words in it. What would it even make sense to do in that case? Regardless of what the function does, it'd be hard to say one way or the other whether it was doing the correct thing in a situation where there really is no correct behavior.